In this screencast, we will begin solving linear equations. Essentially, linear equations are equations with the variable raised to the first power. So 2x plus 1 equals 5 is an example of a linear equation, and negative 3 halves x minus 4 equals 5 times the quantity 4x minus 3 is also an example of a one-variable linear equation. We are going to start with simpler linear equations such as this, and we are going to slowly progress to more complicated ones such as this. But to motivate studying linear equations, let's revisit a problem from a previous screencast and had to do with functions. If you can recall, the Radical Gym charges a one-time initiation fee of $120, then $6 per workout. Let W represent the number of workouts, and let T be the total amount of money spent. So W was the input, and we started to use function notation. F of W represents the output, right? So T equals F of W, these two things mean the same thing, is equal to, the rule was 120 plus 6W to get the total amount of money spent. And we answered questions such as, how much money would a person have spent if they worked out 5 times? To do that, we saw that we would plug in 5 for W and look for F of 5. F of 5 represents the output for the input 5. And we saw we can simply plug that into the rule and do the arithmetic, and we've got 150. So if someone works out 5 times at Radical Gym, then they've spent $150. But now we want to address a new type of question. If Keisha has spent $600 in total at Radical Gym, how many times has she worked out? So this example, we would not be plugging 600 in for W like we did with 5 here. 5 was a number of workouts. This is not a number of workouts. This is the total amount of money spent. So this is a value of T, or technically using the function notation, it's a value of F of W. So we're going to put 600 in place of that entire thing right there. We've got 600 equals 120 plus 6W. And notice now that this is a linear equation. The variable W is raised simply to the first power. So we need to be able to solve equations to answer a question like this one here. We are given the output of $600, and it now creates an equation for which we need to solve for the input W. We will solve this equation soon. Some of you may already know how to solve this without much difficulty, but we will wait to formally solve this once we have covered the basics of solving linear equations. The way we solve linear equations is dependent on us being able to write equivalent equations. The definition of equivalent equations are that they have the same solution. So we're going to work to write an equivalent equation to x plus 5 equals 8. Now, I'm sure most all of you can look at this and say, what number do I add 5 to get 8? Well, that would be 3. 3 plus 5 would give you 8. So I know the solution is 3. An equivalent equation to x plus 5 equals 8 will also have a solution of x equals 3. However, we're not going to just fumble around and try to figure out equations that have a solution of 3. We're going to keep this idea right here in mind because this is going to be an essential strategy for solving linear equations. So we want to do the same thing to both sides to get equivalent equations, because we think about equations as balanced. So x plus 5 and 8 are essentially the same weight. They're balanced. It's like two kids on the opposite side of the seesaw. If they're the same weight, then it's going to be balanced. If this kid was heavier, then it would look like this. If this kid was heavier, then it would look like this. But they're balanced right now. So in order to maintain the balance, i.e. to get an equivalent equation, you have to do the same thing to both sides. So while many of you know how to solve this equation already, we're just going to play around and see the types of things that you could do. For example, we could add 2 to both sides. If you added 2 to both sides, you'd end up with x plus 7 on the left, and 8 plus 2 is 10 on the right. This is an equivalent equation to the original x plus 5 equals 8, because 3 plus 7 would give you 10. You could also subtract 20 from both sides. X plus 5 minus 20 would put you at x minus 15, and 8 minus 20 would put you at negative 12. This is still an equivalent equation because 3 minus 15 is negative 12. You could multiply both sides by 3. You get 3 times the left side would be 3 times the sum of x and 5, and 3 times the right side of the 8 would be 24. And again, if we were to sub in 3 here for x, 3 plus 5 is 8. 8 times 3 is in fact 24. So all 3 of these equations are equivalent equations to this one. So writing equivalent equations is going to be essential for our solving linear equations, and it's something you'll be expected to do. However, if any of you have solved linear equations, you might say, well, this is no better, or this is no better, and this is no better than this one was. So we don't want to just randomly do something to both sides, like add 2 to both sides or subtract 20 from both sides. We want to choose something that we're going to do to both sides that is going to simplify this equation to the point where the variable x is isolated by itself on one side. So our objective in solving linear equations is to write an equivalent equation with a variable isolated on one side. And a key thing we need to know in order to do that is the idea of inverse operations. So in general, addition and subtraction undo each other. So for example, if you took your age and added 10 to it, the way you would get back from that new age is to subtract 10 from it. Or if you took your age to start and subtracted 10 from it, the way to get back to your age would then be to add 10 to that new number. And multiplication and division undo each other as well. So if you took your age and doubled it, you multiplied it by 2, that new age would need to be divided by 2 to get you back to your original age, and vice versa. So addition undoes subtraction, subtraction undoes addition. Multiplication undoes division, division undoes multiplication. However, we can't cross between these two. You can't undo multiplication with subtraction. You can't undo addition with division, for example. So these two undo each other, and these two undo each other. Let's now solve the equation x plus 5 equals 8. We are going to write equivalent equations until we've isolated the variable on one side. That then will give us the solution, and we're going to use these inverse operations to undo what's happening to x. So x is not by itself here. X is having 5 added to it. So we want to undo the addition of 5. And the way you would undo adding 5 is to subtract 5. So as we mentioned before, you can't simply subtract 5 from the left side and not the right side, right? If you had x plus 5 and 8 are in balance, if you subtracted 5 from this one side, then this side would be heavier and it would look like this. It wouldn't be balanced anymore. So we need to subtract 5 from both sides. Well, let's go do that over here. People often just write below the equation. So we want to subtract 5 from both sides. You don't actually have to write in this operation here. Eventually, it's actually a good thing for you to not be able to, or not need to, write in the minus 5 and the minus 5. You want to just be able to do it. So if you have x, you add 5 and subtract 5, they undo each other, leaving you just with the x. And of course, 8 minus 5 gives us 3. This is an equivalent equation to this equation, but this equation is giving us the solution to this equation because x is now fully isolated. So we know that x is 3, and since they're equivalent, that means x is 3 up here as well. So x equals 3 is the solution to x plus 5 equals 8. Let's now take a look at a variety of problems. We're going to solve these 4 equations, and I'm not going to be writing anything down here on this balance. Just remember, we've got to maintain balance. That's what an equation is about. So if you've got negative 2x equals 8, we want to write equivalent equations until we isolate the variable x. In this case, it's p over here and q here. But in this case, we want to isolate x by itself on one side. Well, first you have to identify what's happening to x. Is negative 2 being added to x? No. When you put negative 2 up against x, that means x is being multiplied by negative 2. So how do you undo multiplication by negative 2? Well, the inverse operation of multiplication is division. So we are going to divide both sides by negative 2 to undo that. Negative 2 divided by negative 2 is 1, leaving us with 1 times x is just x. On the right-hand side of the equation, 8 divided by negative 2 gives us negative 4. We've done the same thing to both sides of the equation, so this equation is equivalent to the original equation. But this now tells me that the value of x is exactly negative 4. So that means negative 4 is the solution to this equation. So notice my final solution here is x equals negative 4. It's an equivalent equation. You should not be writing just negative 4 as your solution. We want equivalent equations all the way. Let's try this next equation. Again, you have to be able to identify what's happening to the variable, in this case x. Also notice what's different about this is that x is on the right-hand side. It doesn't matter. If you had two kids were balanced, if they switch sides, they'd still be balanced. So we're going to just work with x on the right-hand side. We just need to be able to identify what's happening to it. So x is being divided by 3. How do you undo division by 3? Well, multiplication undoes division, so we want to multiply both sides by 3. And 3 times 24 gives us 72. And on the right side, the 3's divide out, giving us 1, but 1 times x is still just x. So the 3's divide out, and we've got 72 equals x, or x equals 72 is the exact same thing. So the solution to this original equation is x equals 72. Let's try this one. In this case, p is having 7 added to it. How do you undo adding 7? Well, that would be by subtracting 7 from both sides. On the left, we've got 4. On the right, if you had p and added 7 and then subtracted 7, that would give you back just p. So we get 4 equals p, or p equals 4, however you'd like to read that, is the solution to the original equation. And finally, this last one, q minus 22 equals negative 53. 22 is being subtracted from q. The way to undo subtracting 22 is to add 22 to both sides. And if we add 22 to the left-hand side, we end up just with the variable q. And if we add 22 to the right-hand side, we end up with negative 31. So q equals negative 31 is the solution to the equation q minus 22 equals negative 53. Now notice for each of these 4 equations, these were only one-step equations, meaning all you had to do was divide both sides by negative 2 to get this. This one, all you had to do was multiply both sides by 3 to get this. Subtract 7 from both sides here, and add 22 to both sides here. In general, your equations will often be multi-step problems. That's what we'll look at next.